8.4 notes, day 1. We are going to actually start working on trig ratios. And so we're going to talk about how to identify trig ratios, and we're going to talk about how to use them as well. So what is trigonometry? Trigonometry actually comes from two words. The first one being trigon, which in Greek means triangle. Okay, and also it comes from the word metron, which which in Greek means measure. Okay, so basically trigonometry is the study of triangles and their measures. So let's go ahead and talk about the trigonometric ratios. Okay, so we have the three that we're going to start with. There's actually 6 trigonometric ratios, and the 3 we're going to start with are sine, cosine, and tangent. And these abbreviations right here are what you're normally going to see when we're talking about your trig ratios. Okay, so we're going to assume that this angle right here is 90 degrees, and we're going to go ahead and label this triangle A, B, and C for the purpose of our notes. Okay? Alright, so the first thing that I'm going to teach you guys about the trigonometric ratios is what we used to call, whenever we were not so politically correct, SOHCAHTOA, and we would refer to Chief SOHCAHTOA. So basically, SOHCAHTOA is an abbreviation for a trig ratio based on a certain angle. So if we were talking about angle A being our what we would call theta, all right, and I'm going to draw a little symbol there called theta. Okay, so we're looking at that angle A. So the sine of A would be a ratio that would be equal to the opposite over the hypotenuse. And I kind of like to write my so like this, and my ca for cosine like this, and my toa like this. And that helps me understand that the ratio for sine of the angle that I'm talking about, angle A, is going to be the opposite, which is going to be CB side, over the hypotenuse, and the hypotenuse would be side AB. All right, and I'm going to go ahead and work cosine of A. So cosine of A would be the adjacent. A stands for adjacent, so the adjacent side would be AC over the hypotenuse, which would be AB. And then the tangent of the angle theta that we're looking at for angle A would be the opposite side, so that would be CB over the adjacent side, so that would be AC. Okay, so now let's go ahead and talk about angle B. So we're going to move our theta. Our theta was in angle A over there. Now I'm going to move my theta because we're discussing angle B. So we're discussing this angle over here. Okay, so the sine of B would be considered the ratio of the opposite. So O stands for opposite. So the opposite side for B is a different side when we're discussing angle B. So that would be AC over the adjacent, or the hypotenuse, so that would be AB. Okay, so the opposite over the hypotenuse. The cosine for angle B would be the adjacent, so that would be BC in this case, over the hypotenuse, which would be AB. And then the tangent for angle B is going to be the opposite, so AC, over the adjacent. So that would be the side that's right next to the angle. So that would be BC. Okay? All right, so our example number 1 says express each ratio as a fraction and a decimal to the nearest hundredth. I'm actually going to let you guys handle some of your computing of this, I guess, be on your own. I'm going to show you what the fractions are going to be. So I really don't care about this part, but if you want to go ahead and put this into your calculator, that's fine. I'm just not going to show you how to do that, all right? So the sine of p, so we're dealing with this angle here. So I'm going to draw a little theta in that area. And some people draw their theta like I just did. Some people do their theta where they draw kind of like an oval and they put a little line through it. I've always preferred to make my theta like so. Anyways, it's not the best looking theta in the world. We'll get over that. So sine of p, we're talking about this angle right here. So if we remember SOHCAHTOA, we would remember SOHCAHTOA. It's all set up by ratios. So sine of p is equal to the ratio of the opposite side, so 15, over the hypotenuse, over 17. Okay, so sine of p, sine of this angle here, is equal to 15 over 17. It's equal to that ratio. The sine, or the cosine of this angle here is going to be equal to the adjacent side, so 8, over the hypotenuse, which is 17. The tangent of this angle is equal to the opposite, so 15, over the adjacent, which would be 8. All right, and what I'm going to do is I'm actually going to leave these trigonometric ratios for you to come up with. This is sort of like part of your assignment. You're going to come up with these. Now, if you wanted to figure out what the decimal would be for 15 divided by 17, you would literally just plug into your calculator 15 divided by 17. Okay, and that's how you would come up with the decimal for this ratio here, and hopefully you already realized that. Later on, I will actually show you how to calculate some of these ratios using your calculator and using the actual trigonometric functions in your calculator, but right now we're not going to worry about that. I just want you to know what the exact form of these answers would be. All right, so let's move on to this next example, and we're going to talk about the sine of j, the cosine of j, and the tangent of j. So we're dealing with this angle here, okay? And the sine of j is going to be the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. And the tangent is going to be the opposite over the adjacent. SOHCAHTOA. All right, that's how we come up with SOHCAHTOA. All right, so the sine of j is going to be the opposite over the hypotenuse. So we would deal with the opposite side. So this is going to be equal to 5 over 13. The cosine of j is going to be equal to the adjacent, so this side here, 12, over the hypotenuse, which is 13. And the tangent of j is going to be equal to the opposite over the adjacent, so 5 over 12. All right? And so if I were to switch that and go to angle K and move my theta up here, my sine, my cosine, and my tangent ratios would change based on the fact that I'm discussing a different angle. I want you guys to work these three trigonometric ratios as if they were an assignment. So that's going to be part of your assignment. I don't want you to do that right now, kind of like on the last section. I want you to keep that for like your assignment for later. All right, we're going to move down to our special right triangles. We've kind of talked about some of our special right triangles on our previous unit. And so we're going to deal with a 30-60 right triangle. And we're going to deal with these side lengths as if this side length were 1. Actually, let's deal with these ratios as if this side was 1, because that would make this side length here 1/2, and that would make this side length here the square root of 3 over 2. And so I think that will make things interesting. And later on, you will actually see, and I don't know if we'll do it in geometry or if you won't see that until you actually get to Algebra 2. But later on, when you actually deal with something called the unit circle, you'll figure out that that radius right there actually creates an entire circle with 30, 60 right triangles. And that's for a different lesson. So let's talk about what happens with the sine of 30. So again, kind of like what this says in the instructions, it says use a special right triangle to express each ratio as a fraction, and as a decimal to the nearest hundredth. I don't care about this part. Okay, I care about the fraction part of it. If you want to take the time to figure out what the decimals are, that's all cool, but I'm not going to. All right, so I'm going to kind of just leave that crossed off, actually, on my notes. So the sine of 30 degrees. So if we remember so katoa, all right, my sine of 30 degrees, we're dealing with this angle here, is going to be the opposite, so this side length, over the hypotenuse, which is 1. So in this particular case, it's just 1/2. Okay? Because if I divide anything by 1, I end up with just itself. The cosine of 30 degrees. So the cosine is going to be the adjacent side over the hypotenuse. So again, we're going to end up with a situation where we have 1 in our denominator, so the cosine of 30 degrees is just going to be the square root of 3 over 2. And now we're going to deal with the tangent of 30 degrees. So the tangent of 30 degrees is going to be equal to the opposite, okay, the opposite side over the adjacent side. So this one's going to get a little interesting. So I've got 1/2 divided by the square root of 3 over 2. All right? Now, if I remember my algebra rules, this is equivalent to copy dot flip, and I'm going to flip this fraction over. So I would have 2 in the numerator and the square root of 3 in the denominator. In this case, my 2's would cancel out, and I would have 1, where do I put this? 1 divided by the square root of 3. So all of this is equal to 1 divided by the square root of 3. And I need to rationalize my denominator. Remember from the previous unit, I cannot leave a radical in my denominator, so I'm going to multiply by 1, which would be the square root of 3 over the square root of 3. When I do rationalize my denominator, I would end up with the square root of 3 over the square root of 3 multiplied by the square root of 3 is just simply 3. Okay, so this would be my answer for the tangent of 30 degrees. And what I actually want you guys to do is I want you guys to go ahead. You're going to be dealing with a different angle here when you deal with the sine, cosine, and tangent for those trig functions of 60 degrees. What I want you guys to do is go ahead and calculate what that would be using this angle here. Okay, so by now you guys should be getting the hang of this. So what I want you to do is I want you to come up with your 3 trigonometric functions for so this triangle is going to be a 90-degree angle here, and what I want you to do is use this length as 1. So if that length right there is 1, this length right here would be root 2 over 2. And this length right here would be root 2 over 2. And if you have a question about how I came up with these lengths, these side lengths, based on this hypotenuse being 1, that would be something that would be a good question for us to talk about in class, because we did cover this in the previous unit, and if you don't understand that, we need to get that under control before we keep moving forward in our trigonometry unit. So that would be a good thing for us to talk about. Now, I want you guys to actually come up with these 3 trig functions and their ratios as part of your assignment for today. And I also want you guys to complete these 2 questions here. What does adjacent mean? And how do you know which side is